is Muhammad Masyariawan, and today I will explain a topic from phonetic and phonology called phonological structure. In this video, I will explain three main ideas: what phonological structure is, why linguistics need a richer phonological representation, and the last one is examples of phonological process in language. So, phonological structure refers to how speech sounds are organized and represented in language. In phonology, linguists do not only study individual sounds, but also the internal structure that explain how these sounds behave and interact with each other. In phonology, the smallest elements are called distinctive features. Distinctive features are characteristics of sounds that help us distinguish one sound from another. For example, sound p can describe using features like consonant, not syllabic, not voice, and bilabial. Linguists represent this using plus and minus symbol. Example, p is minus syllabic plus consonant and minus voice. This means phonological do not only study letters or sounds, they also study features inside the sounds. Okay, next for the linear phonological rules. In earlier phonological theory, linguists believed that phonological work in linear order. This means sounds were analyzed in sequence from left to right. Final consonant may become voiceless. For the example, dogs become dogs. But in some languages, it may sound like dog like this. These rules only looks at the order of sounds in word. But linguists later realized something important. Not all phonological patterns can be explained by simple linear rules like this. Okay, let's move to the next material, the need for richer phonological representation. Because language is more complex, linguists realize we need a richer phonological structures. Features are related to each other, which mean nasal sounds adapting to nervous sounds. For example, Edinburgh, Derby, Preston, and Cardiff. The sound n changes depending on the consonant that follow it. For example, n become before labial sounds, and become before velar sound. This is called assimilation. The sound changes so that it becomes easier to pronounce. Another interesting example comes from a language called Desano, spoken in South America. In this language, a word must contain either all nasal sounds or all oral sounds. For example, word 1 is all oral sound and word 2 is all nasal sounds. Mixing them is not allowed. Even grammatical particles follow this rule. This shows that some phonological features belong not only to sounds but to the entire word. This idea is important in modern phonology. So, because of pattern like this, linguists realize that phonology cannot be explained by a simple linear sequence of sounds. Modern phonology therefore uses what is called a non-linear model. This model includes syllable, stress patterns, feature spreading, and relationship between sounds. In this model, phonological information is organized in hierarchical structures, not just lines. The structures help us understand pronunciation more accurately. Okay, we move to the next material, 10.2. First, modern phonological theories say that the internal structure of sound is more complex than just a list of features. Phonological processes often affect only certain features, not the entire sound. For example, sometimes only the place of articulation changes, while other features stay the same. Because of this, linguists believe that the features inside a sound must have some kind of structures, not just an unordered list. One example discussed in this section is nasal assimilation. In English, a nasal sound can adopt the place or articulation of the consonant that follows it. For example, in Philadelphia, in Venice, in The Hague, here the nasal sound changes in the place of articulation depending on the following consonant. but the other features of the nasal sound remaining the same. So, this example shows that phonological rules can affect only one group of features, especially the place feature. Another example in this section is lenition, which means sounds weakening. Lenition is a process where a consonant becomes gradually less obtrusive in the vocal tract. For example, the chains can follow this pattern: voiceless stop to voice stop to voice fricative, and voice fricative to liquid or glide. This means the sound becomes more open and more sonorous. An important point here is that during this process, the place of articulation usually stays the same, but the manner of articulation changes. Now, we move to an important concept called feature geometry. Feature geometry represents the features of sound using a tree structure. At the top of the tree, we have the root node, which represents the sound segment itself. From this root node, several branches appear that represent different group of features. Another branch is the supralaryngeal node. This node represents articulatory features above the larynx, mainly in the mouth. Inside this node, there are several important groups of features. The first group is place of articulation. This refers to where the sound is produced in the vocal tract. Example, labial produced with the lips, coronal produced with the front part of tongue, dorsal produced with the back of the tongue. These place features can also have more specific sub-features. For example, the feature anterior refers to sound produced in the front of part of the mouth, such as dental or alveolar sounds. Another group is manner of articulation. These features describe how the airflow is modified during speech. For example, continuant, which tell us whether the airflow continues or is completely stopped. Lateral, where air flows along the side of the tongue. And the last one is strident, which refers to sound with strong friction, like us. Another feature shown in the tree is nasal. This feature is related to the volume or soft velvet. If the volume is lowered, airflow through the nose and the sound become nasal, such as or n. Now, the book gives a specific example of features tree for the consonant t. In this tree, t is the consonantal, is not sonorant, is voiceless. If it has coronal place of articulation, it is minus continuant, meaning the airflow is stopped. This example shows how a single sound can be described as a set of organized features.
In this section, we will discuss about autosegmental phonology. At the beginning of this chapter, we saw that a strictly linear approach to phonology has some limitation. Traditional phonology usually assumes two main ideas. First, segments are separate from each other, and the second, each segment has its own feature. This means that there is normally a one-to-one relationship between segment and feature. However, this model cannot explain some important patterns in human language. When we recognize concepts such as syllables and feature groupings, we can develop a richer way to represent phonological structure. In this section, we will extend these ideas by examining the relationship between segment and features. Let us first consider English affricates such as ch and j. In feature specification, these sounds are usually classified as minus continuant. However, if we look at their phonetic structure, we find a problem. An affricate is phonetically similar to a stop followed by a fricative. A stop is minus continuant, while a fricative is plus continuant. But in binary feature system, a feature can only have one value at a time. So a segment should be either plus continuant or minus continuant, but not both. This creates a problem for linear phonology because aggregates appear to involve both values in sequence. Next, in Chapter 7, aggregates were analyzed using the feature delayed release. This feature distinguishes ch and j from th and the. However, this feature has very little independent motivation. It simply labels the difference, but it does not explain why aggregates behave the way they do. In reality, aggregates start like stops and end like fricatives. Another example is prenasalized stops. These sounds occur in several languages, such as Fula, Sinhala, Kifunjo, and Vijan. Examples include and unk. These sounds are phonetically complex, but they behave like single consonants. They also involve a change in the feature, specifically the feature nasal. The sounds begin as plus nasal but ends as minus nasal. If language has oral stop, b, d, k, nasal stops, um, 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 prenasalized stops, and unk, we might try to introduce a new feature called prenasalization. However, this does not really solve the problem. It only creates a new label without explaining the phonological structure. The deeper issue remains these sounds appear to involve both plus nasal and minus nasal during their articulation. Because of this, the relationship between features and segment is not always one-to-one. To better represent phonological structure, linguists introduced the idea of timing slots. Speech is still linear because sounds occur one after another. So we represent this sequence using C for consonant and V for vowel. For example, the word lap can be represented like this. This means L is linked to the first consonant slot, A is linked to the vowel slot, and P is linked to the final consonant slot. Each position represents a timing slot in the word. In this model, features are connected to segment using association lines. Some features can exist on separate level called a tier. Because of this independence, the model is called autosegmental phonology. This system allows features to behave more flexibly. For example, features can connect to multiple segments, spread between segments, and be removed from segments. Consider the word lap again. Both L and A are voice sounds. Because of this, the feature plus voice can be associated with both segments. Meanwhile, P is voiceless, so it has the feature minus voice. This shows that one feature can apply to multiple segments at the same time. Sometimes, the opposite situation occurs. A single segment can be associated with multiple features. This helps represent complex sounds, such as affricates. For example, the affricate in the word ledge involves features that represent both stop-like and fricative-like properties. Another example involves prenasalized stops. In this case, the feature nasal can be associated with different parts of the segment. This representation helps explain how a sound can begin as nasal and end as oral. Autosegmental phonology can also represent long sounds. Examples include long vowels, diphthongs, geminate consonants. These are represented as one segment connected to two timing slots. This shows that the sounds occupies more time in pronunciation. Another important process explained by autosegmental phonology is assimilation. For example, vowels in English often become nasalized before nasal consonant. In autosegmental terms, this process is called spreading. The feature plus nasal spreads from the nasal consonant to the vowel. At the same time, the original feature minus nasal may be removed. This removal is called delinking. For example, in the word bin, the vowel a is normally minus nasal. However, because of the vowel n, the plus nasal feature spreads to the vowel. As a result, the vowel becomes nasalized. Another analysis assumes that the vowel is not specified for nasality in the underlying form. In this case, the plus nasal feature simply spreads to the vowel, so no feature needs to be removed. Since there are still several more points and the duration doesn't allow, the following points will be explained by my partner.
Before moving to the next topic, I will continue explaining the last few points of auto-segmental phonology that were previously introduced by my friend. One important rule in auto-segmental phonology is called the no-crossing constraint. This rule states that association lines cannot cross each other. In other words, when features are linked to segments, the lines that connect them must stay orderly and cannot intersect. This rule helps keep phonological representations clear and well structured, so the relationship between features and sounds are easier to understand. Next is vowel harmony. Autosegmental phonology is also useful for explaining a phenomenon called vowel harmony. Vowel harmony happens when vowels within the same word share certain phonological features. For example, languages such as Hungarian, Turkish, and Finnish show vowel harmony. In Hungarian, we can see the difference clearly. The word torok means throat, while torok means Turkish. The difference between these words comes from the feature that this feature can spread across the vowels in the word, causing them to follow the same pattern. Next is harmony with suffix. Vowel harmony also affects suffix. When a suffix is added to a word, its vowel may be underspecified, meaning it does not yet have a fixed feature. Later, it receives the feature plus back or minus back from the vowel in the root word. Because of this process, the vowel in the suffix changes depending on the root word. This is why the same suffix can appear in different vowel forms. Next is nasality across a word. Another example of feature spreading is nasality. In some languages, such as Desano, the nasal feature can spread across an entire word. This means that all voiced segments in the word may share the same nasal feature. Through autosegmental representation, the spreading can be shown clearly across multiple segments. These examples show how autosegmental phonology helps us understand features that extend across more than one sound in a word. Hello everyone, in this video I will explain the material about suprasegmental structure. The sections include first, the syllable and its internal structure, second, mora, third, foot, and the last one is structure above the foot. First, I will talk about the syllable and its internal structure. In phonology, sounds are not only studied as individual phonemes, but also as parts of a larger unit called the syllable. A syllable is a unit of sound that usually contains a vowel and may also include consonants before or after the vowel. Understanding the structure of the syllable helps us explain why certain sounds are pronounced differently in different positions. A syllable generally has three main parts: one set, nucleus, and coda. The first part is the one set. The one set is the consonant or consonants that appear at the beginning of a syllable. The second part is the nucleus. The nucleus is the central or most important part of the syllable. It is usually a vowel sound. The third part is the coda. The coda consists of the consonant or consonants that come after the nucleus. Now, let's look at an example from the book. One example given is the phrase Dear Queen, which can become queerdin in a sponerism. So, Dear Queen becomes queerdin. What is interesting here is that only the initial consonants change, while the rest of the syllables stay the same. This example shows that the beginning part of the syllable called the one set behaves as a separate unit in the structure of a syllable. Because of that, phonologists argue that syllables have an internal structure consisting of the one set and the rhyme. After understanding the structure of syllables, we can move to another concept related to a syllable, which is mora. In this approach, the internal structure of a syllable is described in terms of syllable weight. In some languages such as English, Latin, and Arabic, stress can depend on whether a syllable is light or heavy. A light syllable usually contains a short vowel and no coda. Its structure can be represented as CV. A heavy syllable, on the other hand, can have either a long vowel or a consonant in the coda. For example, the structure can be CVV, such as a syllable with a long vowel, or CVC, where a consonant appears after the vowel. There can even be more complex structures like CVCC, where two consonants appear in the coda. In this system, each unit of weight is called a mora. A light syllable usually contains one mora, while a heavy syllable contains two moras. Because of this difference in weight, heavy syllables often attract stress in many languages. This mora-based analysis helps phonologists explain how stress patterns work and why some syllables are more prominent than others. Besides syllable weight, phonology also studies how syllables are grouped to create rhythm in words. This is explained through the concept of foot. A foot is a unit that groups one or more syllables together. Usually, a foot contains one stressed syllable and one or more unstressed syllables. Look at this picture. This picture shows several types of foot structures based on the position of the head and the number of syllables in the foot. The first type is the binary left-head foot. In the structure, the foot contains two syllables and the stress falls on the first syllable, so the pattern is strong-weak. The second type is binary right-head foot. This foot also contains two syllables, but the stress falls on the second syllable, creating a weak-strong pattern. Another type is unbounded right-head foot. In the structure, the number of syllables in the foot is not limited, and the stress appears on the final syllable. The last type is the degenerate foot. This is a foot that contains only one syllable, which itself becomes the head of the foot. Now I will explain section 1044, which discusses the structure above the foot. In the previous sections, we saw that syllables combine to form a foot, and within a foot there is usually one syllable that is more prominent or stressed. However, phonological structure does not stop at the level of the foot. Several feet can also combine into a larger unit. In the diagram shown here, the lowest level is the syllable, which is represented by the symbol sigma. Each sigma corresponds to one syllable in the phrase Jimmy ate a rabbit. The syllables are then grouped into units called feet, which are labeled with the letter F. In this example, the syllables from three different feet. Above the foot level, the diagram shows another unit labeled G, which stands for group. This group contains the three feet that appear in the structure. The diagram also shows that within this group, the final foot is the most prominent one. In other words, the last foot functions as the head of the group and carries the main prominence. This example illustrates that phonological structure is hierarchical. Syllables combine to form feet, and feet can combine into larger units above the foot level. From this discussion, we can see that sounds in language are organized in structure layers. First, phonological structure explains how individual sound features are arranged and how they interact through models like feature geometry and auto-segmental phonology. These models help us understand processes such as limitation, assimilation, and feature spreading. Second, suprasegmental structure shows that sounds are also grouped into larger units such as syllables, mora, and fit. This unit helps explain patterns of pronunciation, stress, and rhythm in a language. Overall, phonology is not just about individual sounds. It studies how sounds are connected, organized, and patterned in different levels of structure. This is why understanding phonological structure helps us explain why pronunciation can change depending on its context in speech.